So just as a reminder, my name is Heather Bryan, and I'm an education specialist with Ohio Natural Energy Institute, and this is my friend Craig Whitaker.
Yes, hi, I'm Craig Whitaker. I'm actually from Massillon Perry, up near the Canton Pro Football Hall of Fame. This is about year 12 for me doing these kind of things with ONEi, and just happy they keep having us back.
Yeah. So we thought that we would review a little bit about how you could share some of this information with students in your classroom using resources that you can find on Ohio Natural Energy Institute's website, which I shared in the chat earlier on, and I can share again as we're moving around today. First, we love this little video that was created for your use on the website. So I'm going to take you out and just kind of as a reflection, kind of a refresher, we're going to show that to you really quick right now.
Oil and natural gas are called fossil fuel because they were created from biotic materials like tiny terrestrial marine plants and animals, long before the dinosaurs. Millions of years ago, these microscopic plants and animals absorbed energy from the sun, which was stored as carbon molecules in their bodies. They died and were buried by layers of sediment, water, and sand. Other microorganisms fed on the decomposing organic material in a process called biogenesis. At the same time, thermogenesis takes place to convert that same biotic material, resulting in both crude oil and natural gas. Specific high temperatures and pressure conditions are required to induce formation of hydrocarbons, such as crude oil, natural gas, and natural gas liquids. In Ohio, some of the key formations that include crude oil and natural gas include the Utica and Marcellus. People who work as geologists, geophysicists, geoscience technicians, reservoir engineers, and petroleum engineers have the knowledge and the tools to find reservoirs of these fossil fuels underground. Geologic time and the rock cycle play an important role in the formation of these hydrocarbons. There are two types of rocks that are important in crude oil and natural gas formation: reservoir rocks and source rocks. You will learn more about these rocks in the video about migration and trapping.
All right. Well, that's just a little bit of information about where these products come from that we are extracting for our natural energy resources. And what we're going to take a little bit of a deeper dive into here is looking at these depositional environments and how can we model these in the classroom for our students so they can understand how we see these transitions, particularly as Molly was showing us from east to west across the state of Ohio, and in our vertical transitions within the rock sequences from the surface all the way down, and how that reflects these changes within these environments throughout the course of Earth's geologic time. So one of the things that we focus on in the classroom as geologists is looking at the particles that make up the rocks. And we start talking about the rounding, the sorting, and the grain size of the particles that make up those rocks. And one of the first exercises that we do with our students is called modeling our sedimentary basins, to get them to understand a little bit about how these sediments are deposited horizontally from our source rock. In this case, we're talking about the Appalachian Basin. So in Ohio, we're talking about the dumping ground from the weathering and erosion that occurred over in the Appalachian Mountains and depositing those materials over here in Ohio and parts of West Virginia and even down through Kentucky. So some of the sediments that we be looking at when we're talking about rounding, sorting, grain size that we're going to use for this are things like our coarse grain gravels. Some particles are well rounded, but most of these are kind of subangular or angular particles. We move into some smaller particles. I'll be using some sand here, and then we get into our really fine grain materials that's going to make up our muds here. It's just kind of it's just from my backyard. I just dug up and threw in here. So that's what I'm using.
As you're moving it around, it's like smoke. Yeah, it's pretty cool.
All right. So
how are we going to put all these together so students can understand what a sedimentary basin is?
Right. So in the exercise, it gives you kind of specific measurements for each of those. I usually just grab a handful of each one and just start dumping them into I have a Winogrodsky column here with some caps on each end of those. And then I would add just a little bit of water to that and then shake that guy up. And when I shake this guy up, and if I tilt it vertically and I leave this run, it's going to settle out based on difference in density, with the most dense at the bottom, least dense at the top. But we want to represent this to the students as a horizontal run. So we want to see the transition from a non-marine transitional environment into our deep marine type environment as we go.
Okay, go ahead.
Okay.
Do that now. I
There
think
we
that
go.
we can show it a little bit better this way. Let's see if we do it this view. For some reason, I think, let's do the speakers. So go ahead and come on up. There, can you
All right.
see us better this way? Yeah, looks like we're doing
There's
a better
our-
job. Let's go
there
over
we-
that one more time. So we
Okay.
want to show them these materials that you could use.
So the sediments, we're talking about a rounding, sorting, grain size. We're just using some gravel that we picked up. We're going to use some sand for our mid-sized grains. And then we go into our very fine grains. These are going to be our sands, our silts, and our clays here to mix in. And what I would do is take a little bit of each of those, put those into our Winogrosky column. And within our Winogrosky column, we'd add some water in there, and we'd shake this guy up. And when we set it this way, we're going to get the separation here based on difference in density, with the most density at the bottom and the least dense settling out up at the top. And if you leave that settle, you're going to get nice clear water up here at the top, and you're going to see those sequenced out. But we want to talk about how we're transitioning these materials horizontally in this direction. So instead of shaking it up and just leaving it sit this way, we're going to shake this guy up, and we're going to tip it on the side and let that water fall from a non-marine to a transitional environment to a deeper marine environment, and then be able to talk about the changes in grain size, rounding, and the sorting of the particles as we move horizontally across the landscape during those depositional environments. So when I get that guy all shook up, and I did this one a little while ago, I end up with an environment that looks something like this, with the shoreline. We would talk about the Appalachian Mountains over here on my left side. Well, it's on your right, but and then as we transition down here, we get into our transitional environment to our marine, shallow marine, and we get over here to our deep marine environments. We have these very, very fine grained sediments. And then what I would ask the students to do is then correlate those sediments that are deposited within this horizontally with some samples that we would have in the classroom. So we have things like our conglomerates, where these would be found in comparison to our coarse grain sandstone that we have, to our black shales that Molly was just speaking about. And then we get into maybe a deeper ocean environment where we get some limestone chalk. So we get some actual chalk there. And what I'd ask them to do is then be able to correlate those this way with what we see going from a non-marine to a deep ocean transitional, which would be, our conglomerates into our sandstones, into our shales, and then to our deeper ocean over here with these as well. So it's just a really nice visual for them to have. I leave this sit out on my desk all the time. The kids come up and shake it, and then we get to talk about what is going on there and why the materials are settling out the way that they do.
And I think it's really interesting, because if the students don't believe you, they could take these materials out and transition them with different materials. So maybe they have some smaller materials than some of these kind of larger kind of granular pebbles and some things like that. So they could do that, and they could allow it to sit this way, and then they could tip it really quick. I'm sorry, I made a muddy mess up here. But this is how you would do it, just so that we demonstrate this really quick. You would shake it really, really good. And again, as Craig mentioned, if you let it sit like this, you're just going to get a soil column. So that's what this would become. But if you shake it really, really well and you immediately tip it, then you'll start to see some of that transitional environment that he discussed down to your marine environment.
That's really good.
Very cool. And Craig
Yes.
came up with this all on his own. So that was really
It's just
cool.
a fun one to be able to get them to understand how we're moving those environments horizontally across there. Now, what we end up seeing here is we're looking at the Appalachian Basin. If you want to go back to the slide deck here.
Right now. So let me find it. Go ahead, keep talking.
Yeah, bouncing back to what we were looking at with Molly. Go ahead and transition to the next slide. She was showing us this Utica shale well example here, with that Utica shale being roughly 7,000 feet below grade. And we start talking about the changes we see within those depositional environments over the course of that geologic time that she was speaking about, working all the way from our Precambrian or our igneous basin all the way down there at the bottom at 9,000 feet, and working our way up to where we have our potable groundwater, which is, just roughly with a couple hundred feet up here at the very surface. And as we track those changes in materials, a sandstone to a dolomite, back to a sandstone, back to a limestone, to a shale, to a sandstone, back to a dolomite, into a shale, and we see all these different changes. Now we can start to talk about, how sea level changed over the course of period of time throughout Earth's geologic history. And this is where we can pull up maps of the state of Ohio over the course of Ohio's geologic history, and we can see how the water level changed. We get those transgressive sequences, and we get those regressive sequences that should show up in our rock record as it correlates to Earth's geologic history. And that's what our next activity here is going to be on. If we want to go to the next slide.
Yeah, sure.
It's how do we represent that evidence of sea level changes in those depositional environments instead of horizontally, but now we need to be able to recognize those vertically throughout the Earth's geologic column. So through all of that rock strata that's been deposited over the course of the last 300 million years or 4.6 billion years, whatever it is, wherever we're at, we want to be able to predict, was that a period of transgressive seas where the water level was rising over that course of time? Or is it a period of regressive seas where the water level is dropping, just like my hair is going away and away and away over time? So
it is shiny up there.
Yes, thank you. So what we're going to be looking at here is how do we predict if it is a transgressive or a regressive sequence here reflected in Ohio's rock strata.
And just before we start, sometimes people get confused by the diagram that you see on your screen. So we've put in there from coarse to the top down to more of a fine-grained sediment at the bottom. Remember, this is a cross-sectional view. So this isn't exactly what you would see if you were out there. This is as we've kind of gone through and created some roadways or some other things, or maybe it's just naturally exposed, but this is more of a cross-section of what you would see over time.
Yeah, so down there in the bottom of that image, you'd see the road down there. I draw my little Ford Festiva I drove in college on my picture and say, this is me driving down the road, and I climbed up this rock wall over here and collected all these samples for you.
Yeah, so let's do this really quick. So at the top, if we take our coarsest rock right here, so this conglomerate, you want your students to go, I want to make sure you guys can see this really well while Craig is speaking, but you definitely want your students to be able to note in that first column there what its grain size it is, so they could get out some measuring materials so that they can go ahead and do that. Then they can discuss the sorting of those materials, the rounding, perhaps what rock types are within that, if they happen to see any form of organics like fossils, whether they're plant, etc., that are in there. And then after they do that description, they want to be able to tell or describe what environment would have created this form of sediment. So you see that in the middle column there. And then after they've, correlated that information together, they would be able to tell you what environment it would have been deposited within. So let's do that together with this first set of rocks.
Right.
Okay, so go ahead.
So my first sample here, my conglomerate is going to be partially rounded to subrounded particles. I got some pore sorting in there because I'm going to have some muds, some sands in there, and I got some gravels. And then, when I describe that depositional environment, we're talking about either, is it a transitional, a non-marine, a marine, or a deep ocean type environment? Probably be picking towards the end of this is either on the land or near a beachfront. So this is either transitional to a non-marine type environment from which is to be found. So the kids would go over to the box on the right over there, and they'd be able to check that box and say that is on the land. And it would be representative of what we would have seen horizontally in our tube here as we move across, that the larger materials were over here in the non-marine or transitional type environments. And then what we would have them do is sequence them out based on grain size, and we go from that conglomerate, we'd be able to move into our next one, which is going to be our coarse grain sandstone that I have here. So here we're getting into more of a transitional into an ocean type environment, depending on the grain size that you have within your sandstone that you're using. And we continue to work our way down. So there's your beachfront. we get into our marine environments. We get into our shales, so fine grain, well-rounded particles, could have some fossils. I should have brought my other one. I have a nice worm fossil in there, worm burrow in there for that guy. And then that would be my shallow marine. And then I get into the deep, deep ocean where I get my carbonate deposits, where I get my chalks that are forming. So here, when we stack these, and Heather is she's gonna try and hold all these up at once. We worked on this earlier.
We did. There might be a big kaboom, you never know. So here you go. So
so we get our sequences here, and it goes from coarse grain to fine grain. So that means the water level is dropping because we have the coarse on top. So this would be representative of a regressive sequence with the coarse material on top. And if they were to flip that over, this is it.
Here we go.
You did it.
You did it.
All right. We go from coarse at the bottom to fine on the top. That means the water level is getting deeper because the deeper ocean environment is up here on top of that sequence. So what I would be able to do then is, using that information, is take that back to what we see here in Ohio. And I pick a specific section here, say, let's go from the Utica Shale up to maybe the Bass Island Salina group, which is going to be a dolomite. Mm-hmm. And we hit that Clinton sandstone just below that. So I go from a shale to a sandstone, and I see these transitions here as we go. They should be able to predict if the fine grain material is on top, was the water level going up? Was the water level going down? Mm-hmm. And tell me if it was a regressive or a transgressive sequence. So running our way through from the Utica Shale up to the Clinton sandstone, we're getting coarser grain materials. So that was a regressive sequence. And as we track that from the Precambrian all the way up, we see Ohio's water levels were continually changing over the course of Ohio's geologic time. During all that deposition, it was those oil-rich shales, or those carbonate-rich shales, that are going to be our production areas for our oil and gas industry.
Yeah, and thank goodness we've got the technology to get down to that natural gas so that we can create all the electricity that we do today in Ohio. I think natural gas is the number one generator of electricity in Ohio right now. So that's fantastic. All right, so we ready?
Yep.
Okay, so as we look here in reflection for the end of our webinar, again, we want to thank Molly Hunt for her expertise as she discussed how just Ohio's geologic history, and specifically areas where natural energy is found and created within Ohio. So we want to make sure that you have, if you have some questions from Molly, to make sure you have some time right now to go ahead and ask them. But do take a look at these reflection questions. So by utilizing the lessons that you see here on Ohio's Natural Energy Institute in the geology curriculum, you'll note that, we've looked at how you can observe transgressive and regressive environments by looking at grain size in your sediments that you have, how geologists like Molly can kind of determine that historical sea level in the rock record, and how we can kind of predict some of those past depositional environments based upon what we're seeing, so that we can find where that natural gas and oil is that is helping us to power Ohio's energy right now. So anything else that you want to?
Yeah, I think, Molly, would you like to share anything based on, those lessons that we just threw out there to you? You got any feedback for us from that, for the kids?
Yeah. I think I thought they were great. I've done those very similar exercises. Those are important things to know. Sorry, you caught me off guard there. I thought they were great. I think that's a great activity. We definitely modeled those when I took, granted, my high school geology course was a college level course. I was very fortunate to have our college level courses, but yeah, I thought that was great. And I love the tie to the well log that we have.
Oh, thank you very much.
Mm-hmm.
Yeah. So one of the things we just want to remind you is that after our webinar today, we will send out a follow-up email. And in that email, you have the slide deck information and the lesson information that you saw today, as well as Molly's contact information, in which she'll be able to share her slide deck with you. We want to make sure we thank Ohio Natural Energy Institute for all of the great resources that they provide to teachers, as well as to remind you that there will be 2 fantastic summer workshops that will be coming up, both a K through 12 STEM STEM workshop that really goes through a lot of the different careers and technology that you see within the natural gas and oil industry, as well as a geology workshop. So, we're hoping that Molly, maybe you'll come back this summer and present for us then as well. And you guys can learn more about the dun because we were really fascinated.
Yes.
Yeah, no, I would be happy to do that.
Yeah, wonderful. That would be great.
Yeah, keep in mind that, on the ONEi website, you can always find these lessons and many more activities available there for you to use in your classroom. Our goal here is just to provide you the opportunity and the resources that you might not otherwise have. And if anytime you need anything, you can get my email, you can get Heather's email. I'm sure Molly would be more than happy to answer any questions you might have. And if you reach out to Sean or ONEi, they could put you in contact with us as well.
And Sean will even come into your classroom and help your students to better understand a lot about the industry as well. So there's a lot of growth right now in the career availability within the industry. So we're really excited to see how that develops within the future. So thank you, everyone. Sean, any last words for the end of the program today?
No, I just want to thank everyone for taking the time to attend. It's a crazy time of year with the holidays coming up. And so, on behalf of the natural gas and oil industry here in Ohio, we hope you have a wonderful holiday, and we really appreciate you taking the time to learn a little bit more about Ohio's geology.